We're going to do properties of quadratics in standard form, okay? If you're in my actual class, it's 5-2. If you're not, it's blah, blah, blah. All right, so here's what you need to know. Quadratic, first off, what's a quadratic equation? Well, who gives a crap about anything but the fact that it has x squared? If you don't have x squared, it's not quadratic. If it's got an exponent above x squared, we will not call it quadratic. We'll call it cubic, quartic, etc., depending on what the largest exponent is. But main thing that makes it quadratic is there's an x squared. That's a review from a long time ago. Now, we've also talked about vertex form because we've done our transformations. Vertex form is, you got the vertical stretch or compression, horizontal translation, vertical translation. Correct? Correct. Yes, ma'am.
What is that?
That's vertex form.
This is gonna look so weird to like when people watch the video. Just like here's some. Like,
Yeah, because it'll all be like in English. Like, what if they don't speak English? Then it'll look like it's all in like Spanish. All right, vertex form. Now, what we're talking about today, though, is not really vertex form. It is something that rhymes with standard form. You guessed it, stranded form. What? Standard form. Okay? Standard form. Okay, if you remember from Algebra 1, well, you know this, but guess what? Y'all don't remember crap, so you don't know this. AX squared plus BX plus C. Ooh, let's make that C a little bigger, right? We don't want to feel left out. Okay, now, f of x. Okay? That's just like saying y equals all this stuff. Okay? Fancy. All right, now, that is standard form. This little guy right here. That's important to remember. Now, what I'm going to do is I'm going to hit you with all the important stuff you need to know about what it looks like in standard form. Okay? First thing. This is all the information you can get from an equation like this. Okay? Sorry, that was bugging me. Okay. First thing you can find out. From looking at this, I can tell whether or not this parabola is going to be an upward-facing parabola or a downward-facing parabola. Okay? All you look at is your a. Okay? The very first number in front of x squared. So, upward, it goes upward, upward-facing parabola, if our a is greater than 0, which means it is positive. Very good. Downward, you can probably guess, because if a is less than 0, which means it is a negative. Yes, ma'am.
How do you spell parabola?
P-A-R-A-B-O-L-A. Parabola, if you're a weirdo. All right? Downward facing is a is less than 0. Okay? Goody gumdrops, which, if you'll remember, is also called the x, reflection across the x-axis. But you don't remember that. Okay, number 2. Second thing we're going to learn today. We need to learn about how to find the axis of symmetry. Have you ever heard any other axes? Yes, you have. You've heard of the x-axis and the y-axis, correct?
Yeah.
Well, the axis of symmetry is specific to our equation. Say we have a parabola right there. The axis of symmetry will cut it so that it is symmetric. Okay, if I'd have drawn this better, it would look better. But you want it to where if you folded it, it would just be folded upon itself. Okay? Does that make sense? Of course it does, because I explained it. What point is that always going to hit on our parabola? That's correct. It's always going to hit the vertex. Okay? This is the axis of symmetry. This little dot is the vertex. Okay? They're going to be related. Just like the Kardashians are related to stupidity. Okay? Now, so the axis of symmetry. You're thinking to yourself is, that sentence didn't go correctly. What you're thinking to yourself is, Mr. Tarver, how am I supposed to find the axis of symmetry just by looking at the equation? Well, I'll tell you, first off, you sound pompous. Second off, this is all you got to do. You ready? Axis of symmetry. You do negative b over 2a. That is your equation, and that's what you do. All right, we'll get one, girl. All right? That's your axis of symmetry. The end. You would plug in the b. You'd plug in 2 times the a. Put a negative in front of it. Solve it. We're going to do an example, so don't get crazy. All right, third thing.
Okay, wait.
What you got?
Negative b over 2a is what?
It is the formula to find the axis of symmetry. Now, vertex. If you want to find the vertex by looking at our equation in standard form, all you got to do, what did I say? These things are going to be related? Yeah. Look at that. The axis of symmetry goes through the vertex. Therefore, the vertex, the x will always be whatever the axis of symmetry was. Okay? That'll be negative b over 2a. Okay? Cool. All right, now, to find our y, all we have to do is we plug in what we got for x into x, and that'll give us our y when we work the equation. So the way I'm going to write it is f of negative b over 2a. I know you probably can't see it if you're watching the video, but it's just like saying plug it in to find it, which we're going to do an example. It'll be easier, I promise. Okay, and the last thing, this is the easiest thing you'll ever do in all of your math of ever. Sorry, I just burped inside my head.
Wait, what does the F mean?
F just means the function of this, the f of this. Like when you plug this, whatever you got in for that, plug it in for x and solve for y. I'll show you in the example.
Okay.
It'll be easier when I show you the example. Last thing is if you want to find the y-intercept. All right, now this is tough, so please pay attention. If you miss this, you'll never, ever be able to figure this out. The y-intercept is always the c. You're done. That's all you got to do. You just look at whatever number and kicking it with no x. And that's your y-intercept. Okay, let's do an example. Because I know you're thinking to yourself, I want to do an example. Cool, me too. Okay, that's getting on my nerves the way that box was set up, so I'm erasing it too. Okay. We've got ax squared plus b of x plus c. Now, I'm going to do, you can't see that, so I'm going to write it down. I wrote an equation earlier. We got negative 2x squared plus 8x plus 5. Okay, and this is all the stuff you'll have to do for the assignment. If you're in my class, if you're not, you'll probably have to do this anyways. Okay? Now, we've got our a is negative 2, our b is 8, and our c is 5. Okay, first thing, want to know if it's upward or downward. I told you all you got to do is look at your a. Is our a a positive or negative number? Negative, therefore it goes downward. Okay, so it's a negative 2. Second thing, axis of symmetry. That's negative b over 2a. So, b is 8, negative 8. I put it in negative because it starts with a negative. Okay, it was a positive 8, so I put 8 in there. Over 2 times our a, which is negative 2, correct? I'm going to bring the negative 8 over. 2 times negative 2 is negative 4. That reduces to 2. All in favor say, okay.
Oh, okay.
What are you lost about?
What's the A? Where'd you get the A?
From there.
Okay. Never mind. I'm back.
Welcome back. Alright, now, that's my axis of symmetry. Remember I said that my axis of symmetry is related to the vertex? Because it always crosses through the what of the vertex? The x. That's always going to be the x. Oh, I'm sorry. The axis of symmetry is a line. So we got to draw it like it's a line. Okay, x equals 2. Remember we talked about in linear programming? It's the opposite of what you would think. If we're plotting that line, we know we're always going to go over 2. Doesn't matter how much we go up or down, we're always going to go over 2, so it makes that line vertical. Make sense? Cool. X equals 2 is our axis of symmetry. Our 2 is our vertex, because we know this crosses through the vertex. Now, our y. What we do is, we plug that 2 into our equation for x. It's an x. We want to find the y. We've been doing since we started living math life. What? Alright, so we find f of 2. That just means we're going to find it whenever x is 2. So we got negative 2 squared. Just did that part. Now I'm doing plus 8 times 2 plus 5. It's a 2.
Okay, sorry.
Alright, 2 squared is 4 times negative 2 is negative 8. 2 times 8 is 16. That's 5 still. Add that up, that's 21 minus. So that would be positive 13. My apologies. Okay? Is that right? All in favor say okay.
Well, I'm not going to write it down yet.
Alright, well, we're not going to wait on you. Alright, so 13 is our y. We found the vertex. Excellent. Now, from there, I can plot Well, let's not plot to the end. Okay, let's find the most difficult part, the y-intercept. Whatever's in the place of C. 5. You're done.
That was tough.
Yeah, I know, right? I think I'm sweating under my armpits.
That's why you wear deodorant.
Well, that's why you shut your mouth. And stop cussing at me. All right, now, with this information, we can plot this on a line. Now, if you're doing your homework for my class, it doesn't have to be too specific as long as you get the understanding that you know what the crap you're doing. All right, we know it's facing downward. We know it goes through the axis symmetry at x equals 2. We know that's the vertex, and we know the y-intercept is 5. First thing I can do is plot the vertex. 2, 13. I go over 2, up 13. Okay? Now, that's exactly correct, by the way. All right? Now, we know it's facing downward. Well, we're not going to use that yet. My axis of symmetry is at 2, obviously. That's my axis of symmetry, if I feel like plotting that. Now, here's where the other thing comes in for plotting a quick plot of this. My y-intercept is 5. That means it crosses the y-intercept at 5. Correct? Now, how far do I know I went over this way? 2, right? Because I went over 2 that way. To plot the other side of this parabola, I can just stay on this horizontal line and go over 2. I've got enough here to plot a parabola. I know it's facing downward, which obviously this is facing downward. I plotted it. Okay? The last thing you might have to learn or show or whatever is your domain and range. Domain is how far it goes left and right, which we know it's always going to go how far?
2, 4.
Forever and ever to stay at my heart. Yeah, it goes on forever. Okay, so we'll put it in set builder notation. X is an element of all real numbers. Okay, which means X can be anything. All right, range. Now, where are we going to hit our limit? How far can it go down?
Ever.
Forever and ever. Now, how far can it go up?
2, 13.
At 13. That's very good. 13 is going to be your maximum, okay? So, for y in set builder, it would be our y is less than or equal to 13. That's domain and range. I like to box in all the important stuff because, well, I'm a boss. And, yeah, I'll turn that off. Okay. All right, and that's pretty much it. If you're in my class, learn it.
Good luck.
If you're not in my class, do whatever you want. I don't care. You see how close my video?